What's up, potato chips? Today, we are going to talk about solving exponential equations, specifically ones with the same bases. We actually are going to look at ones that don't have the same bases as well, but we're gonna finagle them and make them the same bases. So, buckle your bootstraps, pull on your big kid chonies, and get ready to learn. So let's start with talking about an equal sign. You're gonna say, Mr. Barton, don't toy with me like this. I know what an equal sign means. So let's talk about it, just to make sure. It's not that I don't believe you. It's that I've been lied to before, and I'm just not ready to be heard again. Okay, so let's talk about it. For today's lesson, we need to look at the property of equality. What does the equal sign mean? So if I say 7 equals 7, that's pretty obvious, right? Like the number of things here is the same as the number of things here, right? But what does it mean if I say like 3x equals 6? Well, it still means the number of things here are equal to the number of things here, but it's saying that even though they don't look the same, they are the same, and I can compare the two sides. I can say, all right, well, if this side is 6, this side must also be 6. So what number times 3 is 6? And it can help me solve the problem, right? So it means that we can compare the two sides and say, well, if that's the same, then this should also be the same, right? So let's look. So the property of equality for exponential equations, let's look at this problem. If I say 2 to the power of x equals 2 to the power of 5, this equal sign means that they are the same. So if they have the same base, and this 2 is to the 5th power, that tells me that this 2 must also be to the 5th power. I'm allowed to say x equals 5. If the bases match, the exponents also need to match. So it lets us kind of throw away the base and just set the exponents equal to each other. And we're going to take advantage of this today to solve exponential equations. So let's see how we're going to do that. Let's look at this. So we have 5 to the power of 10 equals 5 to the 2x. Now what we could do is do 5 times 5 times 5 times 5 10 times. And then we could take whatever huge number that is, and we could say 5 to the 2x power equals the big number, and then we could rewrite it as log base 5 of the huge number equals 2x. But that's too much work, because this you have to put in your calculator, and this is much simpler than that. Okay. What we can do is we can say, since they're the same base, the exponents are the same, so we set the exponents equal to each other. 10 equals 2x, and this is easy for you to solve. You just divide both sides by 2, and x equals 5, and that's the answer. It works on things that have slightly more complicated exponents. Because our base is the same, we set the exponents equal to each other. 2x plus 1 equals 7x minus 5. Now we move all the x's to one side and all the numbers to the other side. So let's move the 2 over here. Minus 2x. I could remember how to draw an x. 2x minus 2x is 0, and these cancel. Bring down our 1 equals 7 minus 2 is 5x. Bring down our minus 5. Now we add 5 to both sides. These cancel. We get 6 equals 5x. And then we divide both sides by 5. And we get x equals 6/5 or 1.2 if you like decimals. Cool. There we go. Easy. All right. Let's remember a couple of properties of exponentials that we learned last unit. And then we're going to do a few more slightly harder problems. So we need to remember specifically the product property. If we have x to the third times x to the first times x to the fifth, We can simplify this by just adding all the exponents and making it a single base with all the exponents added together. So we're going to use this property to solve some of these next questions. All right. So we have 5 to the 3x power times 5 to the x plus 1 power equals 5 to the 3x minus 7. So we can't use this trick if we have multiple things. If you had 5 to the 10x plus 3 equals 5 to the 2x, you can't set these equal because this plus 3 messes it up. Same thing if you had 5 to the 10 equals 2 times 5 to the 2x. This doesn't, you can't just set this equal to this because this times 2 messes it up. So we need to make this one term by using our product property of exponents. So because these are having the same base and they're being multiplied together, we add the exponents. So 3x plus x is going to be 4x. Bring down our plus 1. So this is 5 to the 4x plus 1 equals 5 to the 3x minus 7. Now that we have one term equals one term and the bases match, we get rid of the bases and we say that the exponents are equal to each other. And then this is an easy problem like the ones we've seen before. So we'll move the 3x over by subtracting 3x. So these cancel. 4x minus 3x is just x. Bring down our plus 1 equals negative 7. Add the 1 over, or pardon, subtract the 1 over. Inverses, Mr. Barton. X equals negative 7 minus 1 is negative 8. So x equals negative 8. Okay. So far, these have been easy. Either just set the exponents equal to each other and solve, or sometimes we have to use the product property to kind of condense this a little bit, make it one thing, and then set the exponents equal to each other to solve. What if we have ones that have different bases, though? If that's the case, we can't just set stuff equal to each other. What we need to do is make them the same base. For your homework on this lesson, you will be able to turn this into this by doing this magic trick. This one magic trick that doctors don't want you to know. Actually, they probably don't care if you know it, but you get, it's, never mind. So let's talk about how do we create the same base. We can turn 9 into 3 to a power. So 3 to what power is 9? Right? Well, 3 to the first power is 3. 3 squared is 3 times 3, which is 9. So we can replace 9 with the 3 to the second power. Okay. Let's talk about how we would do that if you had something crazy like this, right? Like 8. The way you can do this without just checking all of the exponents, right, is you can factor this. So 9 is 3 times 3. Oh, this is the base I want. So it's going to be 3 and then count how many there are. 1, 2 to the second power. So once we have factored this and turned it into the base with a power, now it's just like all of our other problems. So we have 3 to the x plus 1 equals 3 squared. We set the exponents equal to each other. X plus 1 equals 2. And we subtract 1. So x equals 1. Good to go. There we go. We're done. We got it. Perfect. Let's go practice that. So we have 2 to the x plus 2 equals 8. So we're going to factor the 8. So 2 times 4. And 4 is 2 times 2. We're trying to get 2's because that's the base we have. So we have 1, 2, 3 2's. So 8 is 2 to the third power. So we have 2x plus 2 to the x plus 2 power equals 2 to the third power. Set the exponents equal to each other. X plus 2 equals 3. Sorry, x plus 2, not 1. Subtract 2 on both sides, and x is 1. That's our answer. All right, what happens if we have a power outside? So let's look at this. We already know that 8 is 2 cubed. So this would turn into, where the 8 is, you replace it with 2 cubed. And then you still have this exponent of x on the outside. Then we know from our exponential unit that if we have something with a power, parentheses to a power, you distribute the power in. So x times 3 is going to be 2 to the 3x power. And now we're good to go. So 2x plus 1 equals 3x. Then we're going to subtract 2x to get it over here with the 3x. These cancel. We have 1 equals 3 minus 2 is 1x. So x equals 1 again. That seems like their favorite answer because it's been the answer the last 3 times. Hopefully this one isn't it. All right, so we have 3 to the power of x. We need to condense or maybe factor our 81 down so it's 3 to a power. So 81 is 9 times 9. 9 is 3 times 3. So we have 1, 2, 3, 4 3s. So this is going to be where the 81 was, 3 to the 4th power, to the power of x plus 1. Then we distribute the exponents together. So 4 times x plus 1. We're going to have 3 to the power of x equals 3 to the 4 times x is 4x. 4 times 1 is 4. Now we set the exponents equal to each other and solve for x. So we have x equals 4x plus 4. Then we are going to move all the x's to one side. So I'm going to subtract 4x to get it over here. So minus 4x minus 4x. These cancel. We have 1 minus 4 is negative 3x equals, bring down our 4. And then we divide both sides by negative 3 to get the x by itself. So x equals 4 over negative 3. And that's our answer. Cool. Is that it? Nope. It looks like we have a couple more. These ones are a little funky because they're in the bottom. So let's see how we do these ones. Remember, there is a rule for exponents that says if we have, let's say, 5 to the negative 2 power, we can rewrite that by taking this and moving it to the other side of the fraction and making the exponent positive. So it'd be 1 over 5 squared. We can do the opposite of that, and we can move it to the other side of the fraction and then make it negative and reverse the process. So here, we can take this 3 to the 5th power, and we can move it to the top, and we change the sign of the exponent. So we're going to have 3 to the power of x equals, move this up to the power of negative 5. See how that works? Instead of making it positive, we're making it negative. We're just undoing the process. Now we just set our exponents equal to each other, and x equals negative 5, and you're done. Okay, this one we'll put it all together. So first of all, we need our 9 to be a 3. So we factor it, and we get 3 times 3. So this is 1 over 3 squared. Then we need to make this into 3 to a power instead of 1 over 3 to a power. So we take this, move it up, and turn our exponent negative. So we're going to have 3 to the 2x power equals 3 to the negative 2 power. Then we set our exponents equal to each other. 2x equals negative 2. Divide by 2, divide by 2. X equals negative 1. And I think that's it. That is it. There we go. You're done with your notes. That was even shorter and easier than the natural log lesson. So if you have questions or you need help or you're not really understanding this, making the bases the same business, please go ask for help. Don't just sit there and struggle. Don't just sit there and sob into your pillow and tell your dog that you hate math and say you hate this class and say, I'm going to drop out. This is stupid. Why do I need to learn this? How about you just stop complaining and ask for help? Oh, but Mr. Barton, I don't want help. I want to complain. I know how it is. But let's maybe take the high road, maybe seek for self betterment, self improvement. Ask yourself, what would Goku do? Would he settle for not being good enough? Or would he push himself to be better? All right, I'll see you guys next time. Have a great day.